Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In today's video we will learn the next question number 4 related with exercise number 9.2 relevant with chapter number 9 differential equation related with the topic homogeneous differential equation. So let's move toward exercise 9.2 FSC part 2 mathematics differential equation lecture number 9 chapter number 9. This is the 9th video of this chapter number 9. Question number 4 tells that reduce the following differential equation in the standard form of a homogeneous form and then solve. It means the given differential equation is not in homogeneous form. First we will convert into homogeneous form, then we will solve. So move to solution. The given differential equation is x dy by dx is equal to y plus square root of x square plus y square. Divide both sides with x. So over here x can start with x, we left with dy by dx is equal to, we can write it y by x and plus over here it can be written as x square plus y square under the root and divided by this x can be written as under root x square, because square can start with under root, we again left with x. After this it become dy by dx is equal to y by x plus over here we use the property, so we will write this and this numerator and denominator in a single radicand. It become x square plus y square over x square. Further simplify it, so it become dy by dx is equal to y divided by x plus x square can start with x square, we left with 1 and y square by x square can be written as y by x whole square. Now this is actually the differential equation form. So we will solve it through the substitution method. So let y is equal to vx. Derivative of this function equation will be dy by dx is equal to, use product rule, so first function derivative of this x with respect to x is 1 plus second function x derivative of the first with respect to x is dv by dx. So putting these two values in this differential equation, so dy by dx is actually v plus x dv by dx is equal to y by x. From over here y by x is actually v plus under root of 1 plus y by x is actually v from over here. So it will become 1 plus v square. We cancel out with v, so we left with x dv by dx is equal to square root of 1 plus v square. Now using separable differential equation, so it become dv divided by square root of 1 plus v square is equal to dx by x. Taking under root on the both side. Now over here let's suppose v is equal to tangent theta. So my dv will be actually equal to secant square theta and d theta. So further it become integral of dv is actually secant square theta d theta divided by 1 plus v square. So v is tangent theta, so tangent square theta. So 1 plus tangent square theta is equal to secant square theta, and secant square theta under the root is secant theta, and is equal to integration of 1 over x dx is ln x and plus ln of c. So secant is cancelled with 1 of the secant theta, so integral of secant theta is ln of secant theta plus tangent theta is equal to, use product rule, so it become ln of cx. On the both side ln cancel out with each other, so secant theta from over here tangent theta is v, so 1 plus tangent square theta is equal to secant square theta. So my secant theta will be actually 1 plus tangent theta is v, so 1 plus v square whole under the root is secant theta. So put over here, so 1 plus v square whole under the root and plus tangent theta is actually v is equal to cx. Now my v is actually from over here y by x, so it become 1 plus y square by x square whole under the root and plus v is y by x is equal to cx. Now using this initial condition, x is 4 and y is 3, so put over here, so 1 plus y square, so y is actually 3, so 3 square gives us 9 divided by x square, x is 4, so 4 square will give us 16 plus y by x, y is 3, so 3 divided by x is this, x is actually 4 is equal to cx. So c is not given and x is 4, so 4c. Now from over here by simplification, 16 plus 9 it gives us 25. 25 by 16 whole under the root will give us 5 divided by 4 and plus 3 by 4 is equal to 4c. Taking LCM, so it become 4 plus 3, 5 plus 3 8. 8 by 4 gives us 2 and 2 by 4 will give us 1 by 2. So the value of c is 1 by 2. Put over here, it will give us the required homogeneous differential equation. Now let's understand the first question furthermore to its required solution. We got this equation 1 plus y square by x square whole under the root plus y by x is equal to cx. We also got the required value of this constant c is equal to 1 over 2. So put over here 1 over 2. So this will come down as it is and x will multiply with c. C is 1 over 2, so it becomes x by 2. Now over here become x square plus y square whole under the root, and x square under the root will give us just x, plus y by x is equal to x by 2. Now take LCM x, so in the numerator we left with x square plus y square whole under the root plus y divided by x is equal to x by 2. Shift x on this side, it become x into x will give us x square by 2. Shift y on the right hand side, it become negative y. Taking square on the both sides, so it become x square plus y square, and the root will cancel out with square, and over here become x square by 2 minus y whole square. X square plus y square comes down as it is. Required formula is a minus b whole square. So a square gives us this plus b square gives us this minus 2ab will give us this. Now further, y square cancel out with y square on the both sides. So x square is equal to x power 4 over 4 minus x square y. Shift x power 4 over 4 on this side, it become negative, and this will come down as it is. Now multiply both sides by negative. So it become positive, and it become negative. Now divide both sides with x square. So over here x square, and x square. So x power 4 over x square gives us x square, and 4 will come down as it is. X square will cancel out with x square, we left with negative 1. X square cancel out with x square, we left with y. So this is actually the required solution to the given homogeneous differential equation with the given initial condition and with the given constant value of c is equal to 1 over 2. Now let's understand the next part, the last part of question number 4, part number B. X power 4 plus y power 4 whole into dx is equal to 2x cube y dy, while the initial condition is y upon is equal to 0. This is actually x and this is y. Taking the given differential equation, x power 4 plus y power 4 into dx is equal to 2x cube y dy. First, divide the whole differential equation with 2x cube y. So dividing with our 2x cube y this term, and also this with 2x cube y. X power 4 divided by 2x cube y, it will give us x by 2y into dx. But we will write it whole. So y power 4 over 2x cube y, it will give us a y cube, because y power 4 over y will give us y power 3 over 2x cube. So y power 3 over 2x cube into dx is equal to, they cancel out with each other, so we are just left with a dy. So shift dx on the right hand side, it will move to the division, so it becomes dy by dx. Over here, let's suppose let I considered y by x is equal to v. So implies y will be equal to vx. Implies taking the derivative, so dy by dx will be, according to product rule, it become v plus x dv by dx. Putting this value and this over here, so it will be, over here we have x by y, over here we have y by x, so it will reciprocate, so x by y will be 1 over v. So put x by y 1 over v, so it become 1 over 2v, and plus y by x, it can be written as y by x whole cube. So y by x is v, so it become v cube by 2. So v cube by 2 is equal to dy by dx is actually v plus x dv by dx, v plus x dv by dx. Now after this, shift this v on this side, it become negative v. So 1 over 2v and minus v plus v cube by 2 will be equal to x dv by dx. Take v common, so we left with 1 over 2 minus 1. So over here, this is actually in the division this way, we cannot take v common. So taking LCM 2v, so it become 1 and it become minus 2v square. And also from over here we have 2, so it will give us v power 4 in the numerator is equal to x dv by dx. Now from over here, using separable differential equation, so move this whole term on the right hand side, so they will reciprocate. To v will move to the numerator and this term will move to the denominator, become v power 4 minus 2v square plus 1, and multiplying with dv. Shift x dx on the left hand side, so it will reciprocate, so dx move to the numerator and x move to the denominator, and take indifferent integral on the both side. Dx by x integration is actually ln of x, and this is independent integral, so we will also take ln of c is equal to, if over here I can write it integral of 2v dv divided by v power 4 minus 2v square plus 1 can be written as v square minus 1 whole square. This is a formula, so v power 4 plus 1 and minus 2v square. Furthermore, over here I can solve this out through the substitution method. Over here v square minus 1 derivative is actually 2v dv, which is actually present in the numerator. So it will be actually v square minus 1 power negative 2, so its integration will be v square minus 1 power negative 1 over negative 1, is equal to, on this side we left with ln of cx because this is the product rule of natural logarithm. By reciprocating it become minus 1 over v square minus 1 is equal to ln of cx. So v is actually from over here y by x, so it become y square over x square. 1 can be written as x square by x square is equal to ln of cx. Further simplify it. So x square move to the numerator, it become minus x square, and the division we left with y square minus x square is equal to ln of cx. Now putting the required values, x is 1, so by putting x1, so it become ln of c is equal to x. So x is actually 1, so it become minus 1 over y. Y is actually 0, so it gives us 0. So minus time of x is 1, so minus 1. So ln of c is equal to 1. Taking exponential on the both sides, so the required value of c is equal to e. Now simplify it further.
Now let's simplify it further. From over here we get minus x square over y square minus x square is equal to ln of cx. We also got the value of c is equal to e. By inserting the value of c is equal to e over here, so it become ln of c is e, so it become ln ex. So over here ln ex. This side will come down as it is. Now this come down with as it is. Over here we will use product rule of the natural logarithm, so it become ln of e plus ln of x. So we just did these two terms with ln of e plus ln x. And now ln and e, these are the reciprocal of each other, they will cancel with each other. We get 1 plus ln x, and on this side they will come down as it is. Now reciprocating both sides over here, so y square minus x square move to the numerator and minus x square comes to the denominator. Over here 1 will move to the numerator and 1 plus ln x will move to the denominator. Shift minus x square on the right hand side, so y square minus x square comes down as it is. Minus x square will move to the numerator and become minus x square over 1 plus ln x. Shift minus x square on the right hand side, it become positive x square, and this will comes down as it is. Now over here we have x square and over here we have minus x square over 1 plus ln x. We cannot take the LCM over here directly. So I will multiply and divide with 1 plus ln x. They will cancel with each other. Again we again left with x square. Now over here I do this step for easiness and convenience. So over here 1 plus ln x and 1 plus ln x is same. So this will be the LCM, 1 plus ln x. In the numerator we left with 1 into x square gives us x square, ln x into x square gives us ln x square, and minus x square comes down as it is. So x square and minus x square are the additive inverse of each other, they cancel out with each other. We left with x square ln x in the numerator, and the denominator we have 1 plus ln x. So this is actually the required solution to this homogeneous differential equation with the initial condition y of 1 is equal to 0. So with this question I finish my lecture. Inshallah in the next video I will solve the next question, which is actually the question number 5 of this exercise number 9.2. So thank you for watching, subscribe my channel, and also hit the bell icon to receive the upcoming notification about interesting problems and numericals related with second year mathematics. Thank you.